Welcome guys, it's good to see everyone. This week we have a presentation from our very own Matt Harper talking about Docker, which is a containerization tool, which you guys will find out all about. Containers are really powerful and we hope you guys learned something. Then we're going to have pizza as always and continue working on the project that we've been working on for the last few weeks.
Can you join from your computer, Matt? Join Discord, because I am. Oh, you are? Oh, they can't hear you? No, I'm just testing it. I'm not a slacker like you. It's working now. Wait.
Oh, there might be a volume button.
It's super fast.
I wanted to blast them.
I think it shows a display usually, right? Like when you turn it up.
Probably like once you fold it all up, it's probably like in my taxes. Oh, yeah. Yeah, so it's portability. Yeah.
I think that just right. So I think they can hear you on Discord because it's going out on this side. So they can hear you.
Yeah, it's working. Do you want me to talk?
Sure. Well,
But you might be really loud. Yeah, I hear myself.
it's loading.
Still loading.
The stop stream. Try to restream it here. There you go, Sean.
Or no.
No, we still can't see it.
Well, it's just loading.
Yeah, well,
Why is it?
Let's see.
are you focused on the app? That also. We're not focused on the window.
I think there is a public link to that. You can probably screenshot from there. Just trying to keep track of the changes if we have to.
Wait, what do you mean?
For the presentation, right? That's where you have an issue sharing the presentation.
Yeah, oh, you mean like
Yeah, you screen share. It's
Yeah,
like-
that's interesting.
If you
versus
need to.
presentation.
It's on Git.
Matt, do you want to? I can just go through the presentation as you're doing it and stream it.
I think it should be.
Yeah, because it's still not. Yes, you can just start and I'll do that.
Okay,
Should be the
sorry about that. Anyway, so my name is Matt. I'm here often because I'm still in school. And I will be for quite a long time. So the first thing to point out is I'm not an expert. I'm going to try my best to put at least the basics, and I can at least get that across to you, hopefully. I will generalize things, mainly because, again, I'm simplifying it for both myself and everyone else. And if you notice any spelling errors, I can't spell. And sometimes it doesn't tell me that I did it wrong, so I may have missed something. And I will try and do a demo. I didn't have much time to prepare because I've had a lot going on this week. But watching me fail is fun in its own way, right? So hopefully the outline is that I'm going to go over the basics. So what are containers, what are images, what is the runtime, and then also what is like how those containers work. And then I'm going to briefly talk about Docker files because that's how you can kind of build your own container image and how you can kind of move this application from something that you run bare metal on the machine itself to a container that you can run however you want. And then I'll very briefly go over some CI. So in terms of running it yourself, if you are on Mac or Windows, it gets a little weird because containers, other than maybe a few exceptions, run or are designed to run on Linux, right? So if you're on Windows, it will either, generally you'll use WSL or something like that to run your container. So if you look at all the processes in Windows, you won't really see it because it's under WSL. And, or it might spawn a virtual machine and run it in those, which is, unless it's changed recently, that's what happens on Mac. So if you install Docker engine, Podman, whatever, on Mac, assuming it's supported, it will actually start a little virtual machine and run everything in it because the Mac system kernel, I guess itself, doesn't have the necessary pieces to build containers in the way that Docker does, right? And Linux is relatively straightforward. They have a bunch of install guides, there's scripts all over the place. Generally, you should be able to figure it out. And if you are using Docker, Docker does run a lot of things as root by default. That is the most privileged thing on the system. So generally, you do need sudo privileges to do those Docker commands. And they create a group called the Docker group that lets you get out of typing sudo in front of everything. Any questions so far? Okay, so you can't, most of you that know about containers know that you can't really get out of talking about them without talking about virtual machines because most people tend to be familiar with virtual machines at some point. That is, there are a lot of different types of virtualization. I think the terms are, it's a hypervisor. The hypervisor is something that runs your virtual machine. And there are different types of those. You have ones that run as the operating system itself. So something like Proxmox, VMware EXSI,
ESXi.
Yeah. And then there's more fancy ones like that I've seen more recently, Harvester. With virtual machines, you have a lot of overhead, right? Because each virtual machine has its own copy of the operating system, the kernel. And if you think about it, if you have 15 Windows VMs on a server, you have 15 copies of the Windows operating system, and you might not want all of that overhead, right? And there are benefits to that in that you are mostly completely isolated from each virtual machine. So if you're someone that plays with malware or something, that might be beneficial. But if you're running a lot of applications, it's a lot of overhead that you don't get a whole lot of gain from. The thing with containers is that rather than replacing a operating system like you could with a hypervisor, they call it a container engine, but sometimes they actually don't use containers to run things directly with the runtime now. But the container engine is just something that spawns a lot of processes on the host system that are those containers. And those containers, the name container kind of gives it away, but they contain everything that the application needs to run and nothing else. So if you have an application, a website, it would have, say it's JavaScript, you have your run all the JavaScript libraries that you need and everything else. and you would kind of package it all together into one, an image, and then you can deploy that with the container engine or runtime. Yeah. And the thing about containers is that they don't have that extra weight of the operating system. They run as isolated processes on the host. So the host uses a bunch of constructs to kind of isolate them from each other. Does that kind of make sense?
Yeah.
So rather than building an entire virtual machine, they just isolate the processes and they appear to be their own machine, but they actually aren't. And one of the things that that does lead to is that there are, I didn't get a chance to look into it, but there is a way where you can escape from the container to the host system. And that's what people have been exploring in terms of like attacking these systems, because a lot of services run on containers. And then the other benefit about packaging all your application into one thing is that it's very easy to deploy in a lot of different places because it has everything that it needs to run, and you don't have to worry about the outside environment that it is actually in. Does that make sense? Anything to add? Well, haven't messed up too much yet. So there are these things called container engines. There's a lot of them out there, and again, generalization, but they're generally the thing that we interact with. So if you want to start a container, you use Docker or Podman, and you would tell it what container image you want to deploy, and then any configurations, such as if you want to map ports to it, if you want to give it certain privileges. And they act a lot like any kind of user interface or interpreter, right? You give it a series of commands, and it figures out what it needs to do with the runtime to get you that desired outcome, rather than having to know all those little tiny things that you need, or that the runtime would need to get to deploy your system. And this includes setting up networks and privileges and everything. Yeah. And I guess the thing that I didn't mention is that containers, the images themselves are static. So when you deploy an image, it has a read-only memory region, which they all kind of share. So you can save on deploying something in that they share one copy of read-only memory, and then they each have their own memory that they can write to and make changes to. I don't know if that makes sense, but it is one of the ways that it can help limit the footprint of the thing that you were deploying. The container runtime is the kind of the lowest, not the lowest, but the lowest level that the process uses outside of the kernel, which is the thing that creates and manages those processes. There's a lot of different ones. I only put container D up there, but I think there's one called CRI or something. CRI?
Yeah, either that or I think there's another one that's called Sysbox.
Yeah. And it's run C one too?
Run C, yes, yeah.
Yeah. But these are kind of the lowest level you would probably interact with, and they are what actually deploys and manages those containers. So as I said, they manage the resources, images, and any permissions that you give that container. And one of the things that they do leverage are some primitives in the system's kernel. So I'll very briefly go over some terminology and whatnot, and then go into a very quick demo on how do they kind of build a container and some of the resources that they use. And then I'll try and go over a Docker demo, but it will likely fail because I had a very good year. So when it comes to ports, I assume some of you are familiar with what ports are. So I guess, does anyone know what port 443 is? What it's used for?
I know it's like related to TCP, but
Kind of. Anyone else?
HTTPS.
Yeah. And related to HTTPS is port 80. Anyone know that one? HTTP. 53, I think, was DNS, right? I know 22 is SSH. 23 is, I think, Telnet.
It's either Telnet or SCP.
Yeah, I think it's.
I think or it's the bounce back on that.
I think it's Telnet, and then 22, 21 is FTP, I think. And one is, I believe, Ping.
Yeah.
And then one thing that you should note with containers is dynamic and static linking. You're probably not using a lot of compiled programs when you're putting things into containers, but because a container needs to have everything that process needs to run, if you compile something the way that you're used to in classes here, where you just say GCC whatever, it's going to create something that's dynamically linked. That is, when you start that process, the dynamic linker goes and adds things to it when you start it. The thing with the container is, well, depending on how you build it, it might not have those extra resources that it needs to run. So if you are compiling something to put it into a container, you would need to make it static, which is everything that it needs is compiled into that final executable at the time you compile it. So on a Linux system, what they use to build a container are namespaces, C groups, and then capabilities. The most interesting one, I think, are namespaces, because that's what they actually use to isolate processes. And that's kind of an easy way to show you why and what containers are used for. And then C groups are just used to limit what the container can do. If you deploy a container, imagine if it can use 100% of your CPU, then that makes everything else a little harder to do. So you can use those things to limit it, and that's all managed by the container runtime and the engine. And then capabilities are just something that control the privileges the container has. There's something that you should never do. I believe you can set a container to have all privileges, which is generally bad, because if you have a website and someone breaks into the container that's running it, and the container has all of the privileges, well, they can do whatever they want, which generally isn't a good thing.
One of the privileges they give to a container is manage containers. Yeah.
I'm going to very quickly show something. I don't know how I'm going to do this for the people that are online.
They'll have to imagine.
What?
They'll have to imagine.
Yeah. But the thing is that I don't think I'm extended, so I can't see anything that I'm doing unless I look up like, ooh, that's really big. One second. Let me play. That's better. Better?
Yep, I think much better.
Better. I don't know.
Maybe you could just, yeah, well.
What happened there? Oh, settings reset.
Yeah.
I kept my settings this time. Okay, you're gonna see me struggle a lot because I didn't mirror my display. Anyway, so there are these things called namespaces. I mentioned them. You can look at them with LSNS, and you'll see that mine looks really bad because I am on a Linux system, and Google Chrome decides it needs to isolate things. And if I run it with sudo LSNS, and I enter my password properly, you'll see that there are more namespaces, and they tend to be owned by you. And they isolate all of your processes. There's the command.
And if people have trouble seeing it, just let us know so we
Yeah. So in terms of there's this command called unshare, which I don't think it's, well, they might use like a system call with the same name or whatever, but it's how you can isolate your own processes. It's pretty boring, but you can isolate a lot of different namespaces. There's the mount namespace, which would be whatever your files are. You have the inter-process communication, the network and processes themselves, users, then you have the C groups, the things used to control it, because it would be awkward if a container could control its own C groups. And you also have time, because time, I guess, I didn't read into it. But you'll also see that they have some things that I'm going to use, which I believe is proc. I'm going to use that later. But when I first do something, I'm going to share. Well, I got rid of it, but I want to see the help because I can't remember things today. I am going to do M and E at least, right? So sudo unshare bash, and one other one that I'm going to want is F, because if I don't do that, it yells at me a lot. The idea is that I actually need to fork the process, because if I don't, it gets angry. And one of the things you'll notice is even if I type PS, you'll see a lot of different processes still, even though I isolated the process namespace. But if I go over here, you'll notice there's a slight difference between them. Where if I type PS here, I didn't show all of them, right? But you'll see PTS5. But over here, you see flash. And if I look into, there's this directory of proc, you'll see each of these processes has a file. And you can kind of access them and mess with them. But you can kind of do a fun thing here. Yes. Let's see. So what I can do here is I have a process ID for this check. I can do echo into process number /FD /1, and you'll see high over here, which it doesn't really make sense that I can mess with my other processes while I've isolated it from other processes. That's because I haven't actually isolated it from the files that the processes store things in, which is a little funky, but you'll notice if I say kill, then the process number, it says no such process. So you still can't really mess with the process itself, but you can mess with its files with the way it's done, because I'm not Docker or Podman. I can't do everything myself this quickly. I have a new mention. I assume it's telling me that they can't see things, which I can't share. So, it's decided that this thing is all. So, the other thing is if I go back to the LSNS, we'll see that Ash shows up here now because I unshared. Now the other thing that you can do is there is mount, I think there's mount dash. And you'll see if I do PS, it now appears as P1, and if I look in that proc directory, there is nothing, right? And I definitely can't do anything with this because there is nothing in the proc directory and it is isolated from all the other processes. The interesting thing to note is that the PID of this is 1. In Linux, your init process has the PID 1. If that dies, your system dies. The thing with containers is that the process that starts them, if it dies, the entire container dies, regardless of whatever else you have. Does that kind of make sense? It's a little boring, I think. So, this earlier, but with containers, you have images, they're kind of static, they're unchanged, and you can pull them from repositories, you can build them yourself. Generally, they're built off of some standard. Docker files are very common. I don't know if it's like the official standard or if like it follows an official standard, right? Containers are the actually running instance of an image. So an image is static, it's unchanged in a container. When it's deployed, it's built based off of that image, and then it actually changes some region of memory. And then volumes are a way that you can kind of store data and attach them to containers, because if you don't have a volume attached to the container, well, whatever the container did while it was alive, when it dies, it's gone, right? And then networking, that's its own separate thing that you can create internal networks, and you need to kind of port forward from your host to the container. And then in Docker, specifically they use a thing called a Docker socket because it acts as kind of like a server, so you can actually remotely send commands to Docker. You should never have it exposed to the internet though, because, well, anyone can send things to the Docker socket, and it's not exactly the most secure application in the world. And then there is a thing with Docker, I mentioned it earlier, that it runs as root, and that's not always desirable, right? Because if you're running a service and it's running as root and they compromise it, your whole system can get compromised eventually. So running as rootless is something Docker can do, and alternatives like Podman have that by default. So that Podman is more desirable in many ways than Docker, but Docker is still somewhat popular. And then Daemon is just something that runs in the background, and that is what Docker and others need to run in order to interact with it. So when you do a Docker file, generally you want to name it Docker file. It's kind of like a make file, if you're familiar with that. You can give it different names, but I believe you need to specify a flag when you're building it. And then they just contain all of the instructions that your container engine needs to use to build that thing. And it builds it layer by layer, so if you change one layer, rebuild that layer. And maybe sometimes. That is that. In terms of the Docker, I don't have much prepared for the Docker thing because today was very bad. But the main thing is, when you install Docker, I happen to be running as root because I installed Docker 40 minutes ago. I had to reimage my computer over the summer, and as I said, I don't use Docker that much outside of specific scenarios, and that hadn't come up for 2 months. So, in this case, I'm running as root because I don't want to type sudo every time because I will forget. But whenever you do something in Docker, I can make that bigger. Docker, yes. You'll see I don't have any Docker containers running. I also don't have any images. If I want something, I will use this. Right? So there is this thing called, and I believe there are other repositories, but there is this thing, and we'll see how this like it. Well, that is big. My screen's gonna be all kinds of messed up after this. But there's things like Docker Hub that have a bunch of container images on them. Whatever you'd like to run, you simply say Docker pull and then pull it down and do whatever you want with it. Run it, use it to build another container. You could also just say Docker run and then the container that you want to run. Run. If I do that, it will yell at me that you need to specify run with a series of options and the image name. So something that I can do is Docker run nginx. And then you'll see that it kind of takes up my terminal because that's what it did, because I didn't tell it not to. And you'll see nginx is running, and normally nginx, I think by default, this one listens on 80, something like that. And if I pull up browser and I go localhost 80, you'll see there's nothing, because I also didn't tell it to expose a port to me. If I kill this, because again it is taking my shell, I can say docker run nginx, and I can say d to put it in the tag. I need to put it before nginx. Right? And then it gives me this hash, right? Which represents the container kind of identifier. Yes. And we'll see that there is a container actually running. And you'll see that there's a command, docker entry point. Sometimes a common thing people that are just building them themselves do is they have essentially a bash script that runs the start command and then goes into an infinite loop so it never happens. Or if you have something that's like a server, you can start the server and then when the server dies, the container dies. So we see that this is up and that it does listen on port 80, right? But still, I don't see anything. So one of the things that you do need to do when you do this is docker. So docker run port. Is it a colon? I'm drawing a blank on the P.
I think you're missing the dash.
Yeah, dash.
Dash.
Oh, yeah, the dash piece.
Thank you.
I think you still need
And
the
you'll
colon
need
for
the
the
colon.
ports.
Yeah, I thought so. Yeah. So I believe this one's the host. The first one is the port on the host, and then the second one is the port on the container, right?
Yes.
Okay. I haven't lost my mind yet, although I'm well on the way now. So we'll see. Welcome to NGINX.
Yeah.
Right? Hey.
Get his IP address. You can go there too.
Oh, no, his IP address is 127.0.0.1.
Yeah, don't hack me. Anyway, so, do you want me to keep going?
I'll send you the link.
Because I can try and go over Docker if you want, or if you would want, I can just.
Sorry, what was your
I
question?
can try and go over Docker containers, or Docker files and everything, or I can end it early.
Yeah, go over Docker file actually, because I will try.
Could you go over the Docker file from our project that we're working on? It's a Photos guy on GitHub.
Where is it?
It's on GitHub.
If you go to
Can you send me a link?
yeah, if you type in umlcloudcomputing.org, we'll be able to show you code there. Once you're on the main website, you go to the Activities tab, and once you're on the Activities tab, click on Photos Guy Intro, and that should have a link to the repo.
I also just pinged you. GitHub work.
Yeah, there we go. So if you scroll down and go into the app folder, yeah, the app folder.
There's an app folder?
I think so. Oh,
It should just be
no,
in
sorry,
the-
source folder. Yeah. Okay, and there's the Docker file.
Docker file.
It's
Okay.
a pretty simple Docker file.
Yeah, that's good, because if it was complicated, I wouldn't understand it now. There's a thing you can do with Docker files where you do like a multi-stage build, where you have one build into something and then use that as a source and pull files from it, so you don't end up with a huge container at the end of the day. But I don't know how to do that other than that it exists.
Yeah.
So with this Docker file, you just want me to talk about it?
Yeah, you can talk about it. I don't think you'd be able to run it.
Yeah,
Well,
I
you
don't
could
think
run it,
so.
but I don't know. You don't need to run it as part of the project. You can just run it by yourself or whatever.
I can try. I have to download the whole project because it expects files.
Yeah. Let's see.
This is more for like building the CDK.
Yeah, I could too. Anyway, I guess I can just explain.
I guess the only two files you really need are just the requirements.txt, and you can actually skip.
Well, it needs app.
Yeah, you're right. Yeah.
I'll just say what this does.
Yeah,
and
just
then-
you don't need to run.
That's all.
Yeah.
So generally when you build actually always I think, when you build a container image, it needs to have some kind of base. That base can be something that already exists, like this public ECR, AWS, Lambda, Python. So I believe ECR is the last container registry, right? And then that is, AWS has something that is a Lambda based one that has Python on it, I assume. And you can, as I said, I showed you that Docker Hub earlier, you could build it, you could pull something from there, you could pull something from a local registry that you have yourself. It doesn't really matter. There's also one, because it's kind of like, if you build it based off of something, where did that something come from, right? There are ones that are from scratch, and that's where you kind of have to build the environment yourself, and everything has to have all its own dependencies. In this case, there is a copy command that you can run. And in this case, the first argument is something on your host, right, where you're running this from. And in this case, it would be requirement.text. I assume that's a bunch of requirements for the install because it's used in this run command later. This is a environment variable right, that you can use to define where that root is, where it will be installed on the host, or on the container. Do you know what this is by default?
Good question. Alvin, do you know what it is by default?
Lambda task root is basically the environmental variable that specifies the root directory.
So it's just a root directory?
Yeah, it's not related to environment.
Okay. Then you can specify one or more of the, or zero or more, it's really whatever you want, of this one. And in this case, it will run this thing. It will run pip install, upgrade, and then your requirements. And then when you build this, you'll see that it just kind of runs forever, it downloads everything that it needs. After this, we have another copy that copies everything in the app directory to that Lambda root folder. Then you specify a command. Forget the alternative. Do you remember what it is?
Let's see. Yeah, there's an alternative. EXE? EEX?
Something like
I
that.
think it's easy. Well, no, I'm wrong. Yeah.
Yeah, Lambda functions like require a entry function.
Yeah.
So this is just why it's.
Yeah. All containers require an entry function. Right? In this case, I think someone said something like this.
Workers were an entry function.
Container versus host. I can try in a second. Anyway, so this command, there's my mouse. This command defines the command that's going to be run. In this case, it's main.handler. I have no idea what that does, but it certainly does something. Do you know how?
Basically, when you run the Lambda function, that's the first thing you know.
Okay.
It will take parameters to values.
So it's just like a server that listens
Yes.
for stuff. So,
I think main is the file, right? Main is the file, and handler is the function.
Yeah. The function takes like an API call and response to it.
yeah.
So it's
So in this case, it just starts a server and you just go forever, I guess. If that function immediately exited, the container would die immediately, right? So the expectation is that whatever you're calling the command will run for the lifetime of the command. And I think it's either command or it's the other one, but I think it's command. If you specify command multiple times in the Docker file, it'll actually only take the last one. So if you treat command like run, you'll have a really bad time when you build it and try and run it, because if you did command pip install requirements and then command main handler, well, it would only do main handler and nothing would work because you don't have any requirements, right? I was asked to explain the difference between container versus host ports as well. So the host, I guess I can bring that up, and then I'll end it because I don't want to take too much of your time because I'm pretty boring and this slide with the container architecture stuff. The host is just whatever you're running the containers on. So it is a server, it's your laptop, it's your desktop, it's whatever. And the container is simply just a process on that thing that is isolated from all of the other processes. But you can kind of go in and poke around however you want because you control the root user, and the root user can do whatever. Ports are just kind of like an endpoint on your system. They're kind of just imaginary, right? Your computer doesn't have a bunch of wires that you plug into whenever you want to make a network connection. It's just something that helps tell, helps differentiate what traffic is for what thing running on your system. I don't know if that makes sense, but like if I were to bring this thing back up, if I were to do SS, like these are all of the ports on my system that are running, right? I don't, it's pretty small, but it gets ugly when I zoom in, it gets harder to read, I think, because it's just a wrap. But each one of these ports has, it's either for UDP or TCP. So TCP is like, it keeps the connection going. With UDP, you kind of just throw packets and hope the other person gets it. With TCP, you try and maintain the integrity of all the messages and communications, right? And you can see there's all sorts of things. In this case, we have things that listen on certain either my address and some ports. So 000 means it listens to anything. This just means probably my IP, I don't know, or something. And if it's a star, it's probably whatever. This is IPv6. 127.0.0.1 is localhost, so only things on my system can reach those. And you can see various ports. So like most of your systems have like a local DNS handler, so whenever you go to a website, it caches things locally. So you make requests locally. There is, I believe, you can see Docker proxy. So this is the nginx container getting its traffic forwarded. And so you can also see that this is another one, but in this case it's IPv6 probably.
Yep, colon is like IPv6 scan all.
Yeah. I don't know if that helped at all, but
Essentially what a port is it's just a tag to say, hey, this is, I'm expecting things on this.
yeah.
I'll take care of any requests that are made on port 80 or port 443 or whatever it is. That's what a port is.
Let's simplify what those do. I don't know what that means. I think I don't want to hold you all hostage for much longer. So
All right, yeah, so I think we can wrap it up then, if unless you have anything else you want to go over. But I got
Docker presentation that barely covers Docker.
Okay, great. So I'd just like to add, containers are very powerful, and this is something you absolutely need to know as a developer. Because what that means is, say you're in Computing 1, right? And you're a Computing 1 student, and you have to learn how to compile a C program, right? You have to, and they tell you to use Visual Studio. I believe that's what they still tell you, right? So Visual Studio is a large program, and you have to download it, and that includes the executables in order to run your C programs, right? To compile, etc. But with imagine you have something like Docker now. Instead of suppose you created your Computing 1 program, and you want to share it with your friend, right? Some from another class or something like that. In order for your friend to run the C program, they would have to have C installed, or they'd have to have Visual Studio installed. Now, obviously, that's not ideal. So what you could do in that case is create a Docker container. A Docker container that includes the runtime to run the C program. And all you'd have to do is just do Docker run your image, your container name, and you would be able to run and execute your C program, just like Matt showed us how to do with that Docker run. So this is very helpful for developers. It's not really for end users, but it's great for developers because that allows us to share programs so much easier and package it and execute it. So if I want to get a database running up and easy, I don't have to go and download it. I can just do Docker run or Docker run database or whatever else and expose it to the right ports that I need and the right volumes that I want, storage volumes and things like that. So containers are something very, very powerful, and obviously we can't tell you everything that you need to know about it, but we definitely hope that gives you a taste of what they can do.
The one last thing is, I assume Andrew gonna come and talk about Kubernetes?
Yes, I believe that'll be next week.
With containers, they are very useful in microservice architecture.
Yes.
Right? Rather than one giant program that handles everything, you have a bunch of little programs that handle different parts of it. And that's for like availability, scaling, whatever. And those often get deployed on an orchestration platform like Kubernetes. And containers are very useful for that because you don't know what machine that container is going to get thrown on, but it has everything that it needs.
Exactly, yes. So, do we have any questions related to containers at all? Any mild curiosity questions? Mildly curious questions? All right. If not, then we could probably end the presentation here. We'll take a quick pizza break and then come back in here. And so please give a round of applause. All right. So we can go ahead and take a break. Actually, before everyone gets up, what we're going to do is when we come back for the hands-on section, we're going to ask that, actually we can probably go over. All right, let's take a quick pizza.
Are we turning the recording?
Yeah.
Wait, hang on, don't turn it. What does this do? That's cool.
Nice. Huh.